Hello everyone, we are a research team from National Chiao Tung University, Taiwan. Today we're going to introduce our work, Bridging the Visual Gap Wide-Range Image Blending. In this paper, we propose a new problem scenario in image processing, wide-range image blending, which aims to smoothly merge two different images into a panorama by generating novel image content for the intermediate region between them. The main challenge of wide-range image blending lies in the requirement that the generated content for the intermediate region should be not only visually realistic, but also semantically reasonable to achieve seamless transition from one input photo to another. This task is closely related to several research topics. For instance, if we treat input photos as the given context and the intermediate region is what to be filled, the task of image inpainting appears. By contrast, the extrapolation from input photos towards the intermediate region fits exactly the scenario of image outpainting. However, none of the prior works of these related topics is able to easily resolve the problem of wide-range image blending. Here we propose a deep learning-based model to perform wide-range image blending with all the challenges being well addressed. We adopt an unit-alike framework as the basis for building up our proposed model, which consists of an encoder that takes two photos as input, a decoder that outputs the resultant image of blending, and skip connections for connecting the features between encoder and decoder at each layer. Additionally, in order to generate the content of the intermediate region, we proposed a novel bidirectional content transfer module. Given f-left and f-right, which are the feature maps extracted from the two input photos using the encoder, the BCT module aims to generate the feature map corresponding to the intermediate region, which is denoted as f-middle. To ensure the continuity of the spatial configuration between the intermediate region and the input photos, we employ a LSTM encoder-decoder structure to perform a conditional sequential prediction. First, we split f-left and f-right into sequences of sub-feature maps respectively. And then we use the LSTM encoder to sequentially aggregate f-right into a latent code. Finally, our LSTM decoder takes the latent code and f-left as input to predict f-middle. Besides, as the sequential generation should also hold for the opposite direction, our BCT module is designed to be bidirectional. That is, we apply the LSTM encoder and decoder on both predictions of left to right and right to left direction, and the model weight of both directions are shared. Eventually, the final result of f-middle is obtained by combining the results from both directions. After generating f-middle via the BCT module, the resultant image is predicted from f-left, f-middle, and f-right by the decoder. Although the unit-alike model and the BCT module are sufficient for producing preliminary results, the generated intermediate region might still seem blurry or lack texture and details. Therefore, we adopt the contextual attention mechanism into our proposed method. Specifically, we work the attention mechanism with the skip connections across our encoder and decoder, where the information from the feature maps of the two input images is utilized to refine the feature map of the intermediate region from the decoder. By employing such a revised attention mechanism, we are able to enrich the results with the texture and details obtained from the input photos. Here we show some results obtained from the existing inpainting and outpainting approaches. Both inpainting and outpainting baselines create discontinuous structure in the intermediate region, and fail to smoothly merge the two input photos into a realistic panorama. On the contrary, our blending results demonstrate that our proposed method is able to generate a high-quality and realistic intermediate region, which merges the two input photos with seamless transition while retaining a reasonable semantic configuration. Lastly, here we provide some examples of an interesting application of a proposed method, which utilizes two input photos to generate a full panoramic image that provides a complete cyclic view. Furthermore, we can generate 360-degree full panoramic videos from the predicted panoramic images. Please visit our session to know more details and have discussion with us. Many thanks for your attention.